Okay, this is the next question. -2, 3, 1, 7, 6, -4. So this is the point where n equal to 0, and this is the second sequence. This is 1, -1, 2, 3, -6. Okay, so we see this is the index, right, with the n equal to 0. All right, so we will follow the same procedure. I will start with the k index. Okay, now let's say this is k. Okay, so from where I should start? Anyway, x of k will be fixed all the way, right? So this is h of k. H of minus k should be starting from 1, 2, 3. So I have, this is getting flipped. That is -1, -2, -3, -4. Okay, let me start from say -5. Hope this works. Okay, -5, -4, -3, -2, -1, 0. This is 1, 2. So since x of n has 0, 1, 2, 3, only 3 should be fine for. All right, on the right side. Okay, so let's write the x of k. Right, so x of k, I know that this is the time index 0. So below that I'll write the 1 which is given over there. So this is 3 -2. So 7, 6, -4. All right, so this is the one which we are actually interested in, right? And I'll put zeros everywhere else. Okay, so let's write h of k. Right, so h of k, just write as it is. So below 0 I have 3, this is -6, this is 2, -1, and 1. Then I need to flip this, correct? So perform h of minus k. Right, when you flip this, right, what's going to happen? You are going to get the following signal. So at 0 I'm going to get the same thing, but others will get, right, exchange. So 2 comes here, -1 here, +1 here, and the -6 over here, and I'm going to get zeros all this place. But you see, I have to perform a convolution in such a way that, right, let's look at the previous problem. I'll just slightly go to the previous one just for our reference. So in the tabular format, right, I'll use a different color so that I can, right? Now you can see when I actually started the convolution, my first point in my answer is going to happen at some point where the two signals just start overlap, correct? So because this green colored one, which is actually coming from the left side, it just starts overlapping. You can see here, right? There is just overlap, 1 point overlap, then 2 points overlap, then 3, then 4, then all of them, then it moves out, right? Like that I have to perform the convolution. That is the way of the standard convolution which we have done without knowing this in the previous stage. Okay, but now I have to consider that, because now if I write it in the in a specific format, the format which I have used now, you can observe that there is already overlap, right? I'll show you, right? So let's go back to our case. Now you see, if at all I start convolving the sequences, right, you can observe that the sequence, oh, just one number is missing. I'll just write back. Okay, so that means, so this is -6, 0, 0. All right, now you see, right, the two sequences actually are already overlapped completely, right? It's already entered. I actually expected something like this, right? only 1 or 2 points, right, overlapping is what I'm expecting, right? But that is not happening, right? So it's actually within this range. I just wanted one of the sequence from where I want to start. Then I keep moving this to the right every step and I do the convolution. This is what is my expectation, but that's not happening right now, right? So we have to do that, right? Only when do that, right, we can say yes, that's the standard convolution and that's what is happening. Now I don't get the actual result, I'm going to get the partial result if I do the convolution right now, okay, under this condition. So what I do, I have to, right, start from the beginning where only there is just overlap. So just write a condition, right, where the overlap begins. So let me mark my area of interest, right? What is the region I'm actually interested in? I'll write first, okay. I'll try to highlight that. Let me use a different color for that highlight. So you see, this is the area of interest for me. I'm interested within this range. That's the beginning, and this is the end, right? I'm just interested within this range. That's all. Okay, right. So let me start with this. So the second waveform, the second function, which is actually reached here, right? So this is actually overlapping. I don't want that. I want this overlapping. I don't want this overlapping to happen, right? Basically. So I just want the overlapping with the x of k to begin when I start convolution. So that means this 1 comes here. You see the -1 is here. The 2 which is there on the other side, right? The 3 and the -6. Are you okay? So you see this is here, right? I didn't want the overlap to happen, complete overlap. I just wanted to begin the overlap, right? So it means I have to move it to the left. Now you count how many movements you gave, how many shifts you have done. Count the number of shifts. So shift is 1, 2, 3, 4, 5. All right. So this actually, the function which you have written here is, right. So it is not h of minus k, right? This is h of -5 minus k, because you shifted, right, by 5 units. That is h of 5 minus 5 minus k, because of the shifts, right? Now, as and when you flip the signal, you don't get an overlap. That's the problem. So you see here, in the previous problem, simply you had a function like this and I flipped the function to get a straightforward, right, condition from where I can begin the convolution, right? It automatically got converted into the way we wanted. But right now it is not happening. I have to manually perform that. Are you okay? So you see this, I flipped, I got this, then I manually converted into this. I provide so many number of shifts as required, right? So the number of shifts I decided that I need 5, and 5 shifts is denoted by -5, our standard notation, correct? So I started with this, write the remaining terms and do the calculation and tell me what is y of, now you see what is the n value. Can you tell me the n value? N is equal to whatever you see here. So it's not 5, it's -5. So y of -5 is where I start now. Why not y of 0? Just remember, previously we actually, right, started from n equal to 0, right? That is because n was 0 initially, but n is -5. I had to provide a shift, right? I had to provide a shift first, then only I got this. Right. Okay. Now I want you to do the calculation and give me the answer. So this is directly -2, right? -2. Okay. Now you make another shift. So that is h of add 1 to that. Okay. -4 minus k. So -6 enters into this place. This is +3. Then a 2, -1, 1, 0, 0. So now you calculate what is y of -4. Okay, so that is 5. Then make h of -3 minus k. So there is a 0, -6, +3, 2, -1, 1, followed by zeros. So you will be able to calculate y of minus 3. Right. So you get y of minus 3 as minus 6. Okay, then the next one I have to calculate is h of minus 2 minus k. Okay, so this is 0, 0, minus 6, 3, 2, minus 1, 1, 0, 0. Okay, so this is y of minus 2. Six. Okay, then h of minus 1 minus k, right? So 0, 0, 0, minus 6, 3, 2, minus 1, 1, 0. So I get y of minus 1. So this comes to be 22. Then this is h of, now you see minus 1 becomes 0. This is simply h of minus k. Okay, so 0, 0, 0, minus 6, 3, 2, minus 1, and 1. So you will be able to calculate y of 0. Minus 7. Okay, then let's move further. Now I add 1 to that. So h of 1 minus k, 0, 0, 0, 0, 0, minus 6, 3, 2, minus 1. The 1 which was present here actually has moved out, and we are not interested in multiplying that because x of k is 0. So as a result, now we are able to calculate the y of 1. So this comes to be minus 15. Then we'll move further. This is h of 2 minus k, minus 6, 3, 2. We'll be able to calculate y of 2 now. Okay, so this is 27. Then h of 3 minus k, minus 6 and 3. I calculate y of 3 equals. Okay, this is minus 24. Then we have h of 4 minus k as 6. So I get y of plus 4 equals to, okay, this is minus 36. Okay, so that's the last sample we are calculating, because after this there is no overlapping that can be observed between the two sequences, that is x of k and h of k. There's no overlap and we have this answer. Okay, so please tell me the answer. I'll just write once now. So this is y of n, the result, equal to, what's the first sample? I'll show you that. Okay, we started from minus 5, right? So this is minus 2, 5, minus 6, minus 2, 5, minus 6, 6, 22, minus 7, minus 15, 27, minus 24, and minus 36. Okay, so this is what we got. You can see wherever 0 is there, there is a arrow mark coming up. So that's at minus 7. Okay, so this is the n equal to 0. So actually your result starts from n equal to minus 5, isn't it? So this is n equal to minus 1, 2, 3, 4, minus 5, and the right side I have till plus 4. I actually can verify this. I'll tell you a verification method now. Okay, so this is the rule, right? Just to find out not the values, but to verify from where the signal starts and where the function ends. What is the index? Okay, now let us assume, let x of n, right, has length equal to n1. n1 is the length of x of n, right? In bracket I'll write, say, n1, some number n1 to n2. It starts at n1, goes till n2, so the total length is n2 minus n1 is, oh okay, I'll write l1. I'll give a different notation for length. Okay, so let's say that the length is denoted by l1. So what is l1? n2 minus n1. Okay, and let the second function, that is h of n, right, has the length that is equal to, I'll make it as say L2. Maybe it is directed from N3 to N4. Like maybe this is starting is minus 3, going till say plus 7, something like that. Okay, so that is the actual length. So 7 minus minus 3 is 10. So the function has a length equal to 10. That's what I can understand. All right. Okay. Now let us do things. Then this is what is the result. The result is like this. This implies the length of y of n you obtained by the convolution x. I can simply write x of n convolution h of n, right? Length of this function, I'll call it as L, is equal to L1 plus L2 minus 1. That is the length. Just verify now. So let's go back to this and you verify. So what is the length of your first signal? What is the L1? Count the number 1, 2, 3, 4, 5, 6. L1 is 6. What is the length of the second function? That is L2 equal to 1, 2, 3, 4, 5, right? So what is the expected length of y? 6 plus 5 minus 1. That is 10, right? So I'm expecting length 10 here. Just count the numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, it satisfies. So you got that, right? So this is fine. And also I can actually find the index, right? So to find the index of y of n, in the sense where y of n begins and where y of n ends, right? So the y of n starts at, you see, right, we had the two starting points for both the signals. X1 started at n1, and the x2 started at n3. So the y of n will start from n1 plus n3. That's all, very simple, right? Let's verify that later. N1 starts at a point indicated by n1 plus n3, right? And what is the end point? The same function y, just a second. Yeah, okay. So the function y of n ends at the other 2 points, that is n2 plus n4. All right, let me verify the same thing now. I just want to verify this, whether it is correct for the above problem or not. Okay, so this is n2 plus n4. Okay, yeah, let's just make a point now, so that let's note n1 and n2, n3, n4. So what is n1? In this case, n1 starting at minus 2, minus 2, and ending, that is n2 at, it's a 0, 1, 2, 3. Index, time index. Okay, so n3 is equal to, this is minus 3, and n4 equal to plus 1. Are you okay? That's the time index. Now you do one thing, add n1 and n3. Minus 2 minus 3 is minus 5. I'm expecting the answer to start at, right, minus 5, and add the n2 plus n4, that is 3 plus 1, 4. So I am expecting the function to end at plus 4, minus 5, 2 plus 4. You can see here, this is minus y of minus 5, started at minus 5, right? So it's starting at minus 5 as per our calculation, and it's ending at y equal to 4, right? Sorry, n equal to 4. So you can verify there, or you can verify here. So since this is the 0th index, right? So this has to be minus 5. This is the plus 4, n equal to 4, right? So using this, you can actually verify this. All right. Okay. Now, I'll give you a quick problem to solve, right? By the time you solve, let's try to write a MATLAB program to do the convolution. Okay, so I'll give a very small problem. Okay, so x of n is equal to minus 1, 3, 4, 5. Okay, this is the time index. And the second function, that is h of n, is equal to, I want you to perform the convolution between this function, convolution 4, minus 1, 0, 1. Okay, so here, this is the index. All right. Please perform the convolution and let me know when you have the result. I'll directly write the result, therefore. Okay, this is y of n equals to 4. Okay, this is minus 4. Okay, 13. 15, minus 2, 4, and 5. Okay, right. So where is the time index 0 on this? Second 13, first 13. Okay. Now let's just verify, right? According to this, the values I will be able to verify once I write a code. Okay, right. So you see, the first sequence starts at which point? It is starting at minus 2, right? And it ends at plus 1. Second sequence starts at minus 1 and ends at plus 2, correct? So where should the first, the result starts? Minus 2 plus minus 1. This should be minus 3, which means this is minus 2, minus 1, 0. So just verify, this is the expected 0 position. Okay, and it ends at, as per the rule, 2 plus 1, 3. So this is 1, 2, 3, right? If that is the case, yes, this looks fine. and values I don't have an answer with me, but anyway, let me show you that there are two methods to verify. One is just to write a code. I'll just show you the code and I'll share you the code. As well as once you complete all the homeworks, I'll tell you how to verify them as well. Okay. Okay. All right. Let's hold on to this now. We'll quickly move on to the MATLAB screen so that uh, we can verify, right? We can write a code and we can check how to verify the convolution. All right. Right. I'm doing the convolution of 1D. That's why I'll open a new file by this. Okay, now let's do the right. Now I will take one of the signal as input. Say x is equal to, this is input. You're asking the user to enter something. So you know how to do that, right? So input, enter whatever you want to ask the user. So enter the first function. Okay, so then anyway, I want to go to the new line. That's why I know that the new line character is \n. This is what will be displayed. Then the second sequence, I'll call it as h is equal to, once again, input, enter second function. Okay, that is done. Now, after reading this, let me create a space for results. Okay, so y is equal to, I create the zeros. Okay, I know that how to create, allocate a zeros, initialize a array with the zeros. So zeros of one row, number of columns equal to the number of space required. What is that? It's a L1 plus L2 minus 1, but L1 is in this case length of your first sequence, that is x, correct? Length of first sequence plus, just now we have we recall that in the form of a formula, right? The length of your result is nothing but L1 length of x plus L2, that is length of h, minus 1. So length of x plus length of h minus 1. So many zeros you create, that's all, right? So you see that you have created enough space for now, right? Let's go to the this one. So one by one point I will take and I will accumulate. So I'll start with a for. So for, let me take I is equal to 1, and I want to go all the way till length of my first sequence, that is say x. Again, so I should, for one sample, I should do this for every sample that is present on the second one. So I'll go for another for. So for, say, j is equal to 1 till the length of the second sequence. So what is that? That is h. Okay, so for two for loops. Right, let's create my answer now. Directly I create y. So y of, there are only one, there is only one row, but I have to make the index in such a way that you see this is I, first one is I, always I, it starts from 1, I plus j minus 1. I know that because every time the length is I plus j minus 1, right? That index I'm trying to create, that is equal to its past value. So y of 1 comma I plus j minus 1. To this I keep on adding the product, right? That is a of I multiply with the, not a, sorry, what is the function? Just a second. I think x, sorry. It's x of I. Multiply that with the second function, that is h of j, right? Keep adding this. So this means every term by term, I keep multiplying and adding, right? So the summation is taken care of. So simply this is end of the first loop, end of the second loop. That's all. I think y should be our answer. Right? Let's just check whether this works fine. I'll simply run this code. So it asks enter the first function. I'll just go back to the one which we have written now. So -1 3 4 5. Okay, so this is -1 3 4 5. Okay, that's the first sequence. Enter the second function. You know that it is 4 -1 0 1. So 4 -1 0 1. All right, so you can just check your answer. -4 13 13 15, -2 4 and 5. Absolutely fine. So every value you had calculated is correct, right? Except the index. Anyway, now you know how to correct the indices. Okay, right. So I will share you this code, right? Just verify, and for all other values which you had calculated earlier, right? Just verify the answers by this method as well. Okay, so that's one method of verifying, right? And another shorter method is there. Instead of writing a code, I can also verify the method of the answer I get for convolution using another tabular method, right? Which is a slightly different table than what we have already done, which is a lengthier table, right? Okay, right, that I will be teaching you in the next class.